Welcome to the Prevent the Preventable podcast, where we're on a mission to change the landscape of brain hemorrhages by driving awareness, delivering education, and pushing for real action. Now, brain hemorrhages affect millions of lives every single year. But at the Nathy Kate Moss Trust, we're committed to preventing them before they happen and funding pioneering research to advance treatment for when they do. In this podcast, we'll dive deeper into the world of brain hemorrhages because the more we understand, the more we can create real change, and together we can truly prevent the preventable. Hello, and thank you so much for being with us today. As always, I'm Fiona Moss, Director of the Nathy Kate Moss Trust, and I'll be hosting this episode today. Now, as we slowly creep towards the end of the year, I've been reflecting on the incredible journey of the Nathy Kate Moss Trust this year. How it began as a personal mission to honour Nathy's memory and has grown into a vital force supporting pioneering research and raising awareness about brain hemorrhages. It really has changed so much over the years, and I couldn't be more proud of the direction that we are going and the impact that the Nathy Kate Moss Trust is having. Thanks to the incredible generosity and support of our amazing community, we've been able to fund critical projects at the University of Manchester that are pushing boundaries of what we know about brain injury and recovery. This support has helped researchers explore new technologies and treatments that have real potential to improve patients' outcomes. And we're seeing those treatments come to life across NHS hospitals in England this year, which is so incredibly exciting. And today, I am so thrilled to be speaking with one of those researchers, Olivia Murray, who will be speaking to us about a topic on everyone's lips at the moment, AI. Olivia's groundbreaking work at the University of Manchester, which is using brain imaging and machine learning to improve prognostic models in intracerebral hemorrhage, is opening up new possibilities for how artificial intelligence can transform treatment for brain hemorrhage patients. Olivia will guide us through what are some of the most promising ways AI could help improve diagnosis and patient care in the critical early hours after a brain hemorrhage, the opportunities and, of course, challenges that come with integrating AI into healthcare, and what does the future look like for AI in healthcare. Now, if you're new to the Prevent the Preventable podcast, and if you haven't caught up on Series 1 or the earlier episodes of Series 2 yet, we've already covered a wide range of vital topics, from are brain hemorrhages hereditary, to navigating legal advice after a diagnosis, to what happens in the ambulance when a patient is first treated, how to manage your blood pressure to help prevent brain hemorrhages, and real life stories that really demonstrate the devastating reality of brain hemorrhages. There is so much in there to get your teeth into, to make sure that you do have a listen to those episodes too. Now, if you find the podcast helpful, please do like and subscribe on the platform that you are listening to it on, as this really does help those pesky little algorithms and help us reach more people with all of this vital life-saving information. Or just send it to their friend of yours, because that also does help. But without further ado, let's dive into today's episode. Olivia, hi, welcome.
Hi.
Thank you so much for joining us today. I'm actually really excited about this episode. I've already introduced you briefly in the introduction, but when I first heard about the work that you were doing at the University of Manchester, and there was an option to support you and fund the research that you're doing, I was really, really excited, because I feel that, AI is a buzzword, but it's also something that is moving rapidly and we can't ignore it. And it's definitely something that if we utilize it in the right way, I think it can have huge advantages. And so in an area like this with brain hemorrhage, research and treatment and prevention as well, the more systems and, AI platforms and things like that we can use to accelerate change, the better. But obviously, saying all of that, there's going to be challenges and there's going to be some questions along the way as well. And that's what I'm quite excited about exploring with you today. So, but before we go into all of that, could you start by telling us a little bit about your background in this area of research and your research at the moment at the University of Manchester?
Yeah, of course. It's really nice to be on here. It's nice to hear how that you were excited about funding the research. I think in the past we've had some difficulty with kind of finding that support. I think it's because a lot of hemorrhage research is just a bit underfunded. But yeah, so I came into kind of the AI research sphere during my undergraduate degree, which was in physics, where I did a master's project on AI for predicting outcome after head and neck cancer, so using head and neck cancer CT scans. And I just kind of found that I really, really loved using this kind of emerging technology to kind of help patients. I found that a lot of the physics research I was doing in my undergrad was a bit sterile. It was a bit, I couldn't really see the impact. It was kind of like, okay, you measure you measure this property of this particle, and so what? A lot of people have done it before. So I was really excited to work on this. And we kind of got, in the project, we got abstract accepted, and we got to present at a conference. And it just made me so excited about being able to use, because I love coding, I love AI, I find it really fun. And I was just kind of astonished that I was able to use this thing that I kind of almost view as a hobby. I really enjoy it, to actually make a bit of a difference. Yeah. So that led me on to my PhD project, which was using AI to predict recovery after intracerebral hemorrhage. Not really knowing that much about ICH going into my PhD. When I was doing my initial literature review, so when I started my PhD, I kind of read a lot about the field. I was a bit almost astonished that a lot of the studies, a lot of kind of the seminal work in stroke was done in ischemic stroke, which is a stroke caused by a blood clot in the brain, and ICH is caused by a burst blood vessel. But there really wasn't that much research done on ICH, especially kind of in terms of treatments in clinical trials. So I was actually told when I was writing my thesis, in my PhD thesis viva, when I was writing about potential treatments for ICH, one of my assessors said, "Oh, you should include more here. You should include more of the treatments that are available." But I'd included all of the treatments that were currently available, like in the UK on the NHS, because there's often not that many medical treatments that we can do. So yeah, just kind of struck by how much there was still to go in this field.
Yeah, I think, there's quite a bit in there that I kind of want to just pick up on first, which is, the point that you made around the fact that it's really hard for researchers to get funding. And, I think that's why we were so keen as a charity to make sure that, we are funding that research, because without that research, there's then no advancements in the treatment. Just as you just said, there are very few treatments out there, and it's really understudied. But we can only study it. We can only advance that research with funding as well. So funding research can be a bit difficult. And I have all these conversations with people quite a lot, because it can seem a bit like a black hole. Some people, when people want to fund things that make a difference, they want to see that immediate difference. They want to see, numerically how many boxes that fund has packed up to give on to people, whatever it is. But with research, it's quite hard to do that, especially over time. It's quite often treatments are found by like little bits of progress, a little bit of progress. So I think it's really great to hear you talking about like how important it is as well. So I think it's really exciting to kind of hear how you've like layered up your research and how you pulled from different areas. Quite often when we've spoken to other members of your team, whether it's Stuart or other research from the university, they've spoken about the importance of pulling together different parts of research from the university and not working in silos. And I think you as a person in yourself, kind of a great example of that is you're pulling from your physics, but you're also pulling from even tech and, as well, like now the work on stroke too. So it's great that you're doing this work, and obviously we'll dive into a little bit more about what this specific project is that you're working on at the moment. But AI is a bit of a buzzword at the moment. Let's be honest. I'm at networking events all the time, and there's one which every single time we talk about AI, and what's the best AI platform you're using? What are some of the concerns? How's your particular industry moving forward with AI? But let's break it down. What is AI?
Yeah, I think you're right. It definitely is a bit of a buzzword. And I think people kind of, I guess the general public tend to use the word AI to mean a specific thing. They use it to mean generative AI, kind of like your ChatGPT, Claude. But AI is a huge umbrella term. And a lot of things that are technically AI, you wouldn't really think of as AI. There's a lot of AI currently in clinical practice. So we tend to use a lot of predictive modeling. So there's a model that's been in use for years to predict your risk of an adverse cardiovascular event. which has been kind of validated and in use for a while. Simple things, that's something called a linear regression, where you basically just try and fit a line to some data. You try and find an association between two data points. That's technically machine learning, kind of you're learning iteratively. I guess what I'm focusing on is a part of AI, which is kind of pattern recognition, so image processing. You can kind of treat your kind of AI algorithm as just a really intelligent and kind of trainable pattern recognizer. So if you imagine it kind of, I guess, a little bit like a dog, and your dog's untrained, but it's got the potential to learn something. And so over the course of a day, you kind of feed it bits of information. You say, okay, when you do this, you get a reward. And the reward in the case of AI is you train, you can calculate the difference between the machine learning algorithm's prediction and the true value. So you feed it a bit of data and you know the true value of that data. So say you want to say it's an image and you want to see if it's a cat or a dog, and you have that label. So you give it the image and it predicts a dog and it's a cat. You can say, okay, well, that's completely wrong.
Yeah.
Give it a bit of a slap on the wrist and it takes a step backwards. You give it again, and if it makes the right prediction this time, you reward it. You say, okay, great. You've reduced the loss, which is a difference between the prediction and ground truth, and you take a step in that direction. Yeah. So by taking all those little steps, you kind of show it a big data set of, for a lot of image processing models, it's kind of in the realm of hundreds of thousands of pieces of data. You take little tiny steps down towards a global minimum, which is where the machine is predicting answers which are really, really close to the ground truth. So the loss is minimized, and that's how you train your model. So then you kind of got your dog that can perform a task really well because you've given it kind of incentives and kind of little treats, I guess, along the way.
Yeah.
So that's what I do. So I do a lot of classification and segmentation. So segmentation, so medical images. So I work with brain images. I work with brain CT scans. And to interpret brain CT scans, you kind of need delineations of kind of tissues and brain structures to be able to measure things. So kind of intensity, integrity of certain brain structures. And it's really important to be able to delineate these accurately. So what I've been working on is kind of segmentation algorithms, specifically to look at white matter in the brain. But so we've been doing this training using ground truth kind of delineations of the brain, and we train our model to produce these very quickly and rapidly without any sort of input from people. So that's kind of the AI part that I've been working on.
I think it's a really good way to explain it. I think a lot of people know AI, right? And they understand like how it predicts and how it can work basically without people. But I think understanding how it's built in the background is quite interesting as well. So from the work that you're doing then, you very briefly touched on it there, but you're then building out a software, a program, an AI tool that then can use some of these images, like you said, to make predictions in the future so that you could then pass this tool on to hospitals or clinicians to use. Is that right? Hi, I won't take up too much of your time, but if you're listening, it's probably because you care about making a difference. And the truth is, we couldn't do any of this without you. Whether you've run a race, come to one of our events, whether you donate regularly or have made a gift to us in your will, thank you. You're helping to fund life-saving research into brain hemorrhage treatment. Now, just £33.91 pays for 1 hour of research at the University of Manchester. That's 1 hour closer to improving survival rates and reducing long-term disability for thousands of people. And here's the thing, every pound makes a difference. In fact, if everyone who interacted with Series 1 of the podcast, whether by listening to it or downloading an episode, watching a YouTube clip, or one of our reels on Instagram, if all of those people donated just £1, we could fund half a year of research. And if you'd like to help, the link to donate is in the show notes. And it goes without saying, thank you for helping us save lives from brain hemorrhage. Now back to the episode.
My current body of work, which is funded by the Natalie Kate Motts Trust, is building on some work that I did during my PhD. So what I did during my PhD was I used machine learning to detect the integrity of important white matter tracts in the brain.
And can we just pause there? So white matter is?
Yeah, so I think kind of an easy model to understand about this, I guess, is you have different types of structures and matter in your brain, and grey matter is kind of the cortex. So you can think of kind of that as where the stuff happens. And you create all these electrical impulses between the synapses, and then those need to travel to other places in order to be used. And white matter is kind of the highway along which the impulses travel. So when you have a stroke, if you have your grey matter damaged, quite often your body is quite good at repurposing other parts of grey matter to do the function that the original grey matter did. So you often see if someone's motor cortex is damaged, your brain is quite plastic and can repurpose other parts of your motor cortex or your sensory motor cortex to do the function that the damaged part used to do. White matter is a little bit more tricky because it kind of has set pathways and it's quite hard to regenerate those pathways. So once you kind of close the road, it's quite hard to reopen it. So my PhD was working on measuring the integrity of white matter from a CT brain scan. We wanted to see if we could find a fast and accurate way of measuring whether someone had white matter damage or not based on their diagnostic CT scan. And just I think to touch on the imaging a little bit, almost all ICH patients will receive a diagnostic CT scan at the start of their to diagnose their hemorrhage, but often they don't receive much more imaging, as quite often in stroke pipelines, the CT is just used to determine whether a patient has an ischemic stroke or a ICH. Yeah. Then if a person has an ischemic stroke, they go off to have thrombectomy or thrombolysis and kind of all the treatments associated with that. Whereas if they have a hemorrhage, often it's kind of just okay. Sometimes it's just left to medical management. Yeah. It's really hard to see white matter on a CT scan alone. So ischemic stroke patients have all this white matter imaging available from kind of the MRIs they have in the future, whereas ICH patients often don't have that white matter assessment available because it's hard to see on a CT scan. So my project was using AI to combine the white matter, the information on white matter we get with advanced MRI and just the CT scan to create a model trained on MRI that could assess white matter on a CT. So we created this white matter assessment tool based on just a CT scan and found that it was really good at predicting outcome after ICH. So white matter integrity, as measured by our model, was very predictive of outcome at a year. So building on that, what we wanted to do was incorporate more than just white matter injury. We want to look at background brain health. We want to look at features of the hemorrhage. So potentially whether the hemorrhage is likely to expand, because that can be quite dangerous if a patient has a hemorrhage and then that patient continues to re-bleed into that hemorrhage, which can make it bigger and more dangerous. So predicting that.
And what point would somebody typically have this CT scan? Would it be as soon as they go into the hospital? So it's really early on. Yeah. So it's straight away you can basically say, okay, we have a really clear idea of what's going to be happening potentially. Well, not potentially. Obviously, the idea is make it as accurate as possible. Yeah. So that we can then assess that treatment, what the treatment should be.
Exactly. So it's kind of, hopefully this might be used to guide treatment decisions or just give someone a more accurate idea of a patient's pathway to recovery. So the idea would be to combine this suite of model, our white matter detection model from the PhD, and kind of this background brain health, hematoma expansion prediction into a suite of models to make a prognostic tool, as we call it. So prognosis is an accurate prediction of how a patient will recover. So building this tool based on just a diagnostic CT scan. So hopefully output of this project will be a patient has symptoms of a stroke, goes into hospital, gets a diagnostic CT, and this tool will identify the hemorrhage, will give us information on how big the hemorrhage is, where it is, the likelihood of expansion or not, white matter integrity, and use all of these pieces of information to make a prediction on how well the patient will do, and also give the clinician more information. So it's quite hard to see with the naked eye white matter integrity on a CT scan. But if a clinician knew that the tract was damaged or not, it might influence their decision whether to operate or not.
Yeah.
So I think just giving more so than just a kind of a prediction, just a raw number, giving a clinician, say, an annotated CT scan with just more information.
Yeah, it's very interesting, and hopefully it's that next step, isn't it? I think one of the things that when I've spoken to, other clinicians and researchers, I think one of the word that comes out quite a lot is like this sense of hopelessness. When somebody comes into the hospital having presented with an ICH and a brain hemorrhage, there is this sense of, well, what do we do? This hopelessness. And what I get a sense of is that if we look at the short term first, and then we have a look at the long term in a second, but in the short term, having more information and having a better understanding of what's being presented in front of them will actually support or like diminish a bit of that sense of hopelessness, and actually give people the confidence to be able to take on, certain treatments and actually say, well, actually, if we do this will help, because we can see from this diagnostic tool that hopefully it will help as well. But what are some of the challenges at the moment without tools like this in that short term? What are some of the challenges that people face when people present with an ICH straight away in hospital? If we think about this like sense of hopelessness, why is it so hopeless at the moment in a sense?
Mainly because in the past, there haven't been that many active treatments we can do for someone with an ICH. So with ICH, there's kind of two main mechanisms of injury. There's the initial kind of assault on the brain from the influx of blood into the tissue. And what this does is your skull is kind of a closed unit. It's the skull is rigid, and there's not that much room inside your brain for extra things. And so once you get a massive influx of blood into the brain, something else has to give. So often the brain will deform brain structures which should kind of be in one place, kind of move over to the side. And this is really dangerous. So this can damage surrounding parts of the brain in something we call mass effect, and can even the brain can even kind of herniate through the back of the brainstem, which is really, really, really dangerous. So that's kind of the initial form of injury. However, then if a patient then survives that kind of initial assault, the breakdown of the hematoma in the brain can release toxic products. So the blood's not supposed to be loose in the brain, and your body's immune response to this blood can be quite neurotoxic. So that's another form of secondary injury after ICH. Yeah. So treatments usually try and target these two things, but we've not really shown in clinical trials until recently that surgery to remove the mass of blood improves outcome that much. Until a few years ago, it was kind of thought, okay, well, we can operate if a patient is in danger of brain herniation, and we know that will help because it will hopefully halt that. But the kind of maybe the risks from surgery are almost as risky as the secondary injury. I think that's why we have a lot of pessimism. I think because they're just so hard to treat. However, recently there have been clinical trials which have shown positive outcome in terms of functional recovery. So kind of overall kind of disability of the patient after surgery. So we've shown that people recover better now after a specific type of more minimally invasive surgery, which I think is really promising.
Yeah, I think it goes back to what we were saying right at the beginning, right? Which is like, this research is so important, and your research is important, but also the countless other projects that are now going on within the ICH team at the University of Manchester, and obviously the development at the Jeffrey Jefferson Brain Research Centre is so critical, because there's quite a few different angles that we need to look at this from. How does this treatment help, and how does that treatment help? Because there will be lots of different treatments, and we all have different bodies, and we will respond in different ways to different treatments as well, and bleeds will happen in different areas of the brain, and so that might have a different effect. So I think it's so critically important that we are having these research projects that look at, what does having an operation look like? How could that be best performed so it isn't as risky as the secondary bleed potentially? How can we use different models, etc. So I think it's really exciting, the work that you're all doing, and the fact that it's grown so much over recent years as well. But I think it has to be done, because like you said, otherwise we are where we were even 15 years ago or even 13 years ago when we started the trust and we had the first conversations with the university, and there wasn't really that much happening as well. So I think, I think it's really important that this work's being done. But what about the long term? So, in the short term, there's all these conversations about, do we operate? What's the right treatment plan, etc. How do these models, how does, particularly when we think about this AI model, how does that help us understand, well, somebody's going to hopefully survive this. Mm-hmm. What does that tell us about the life that maybe they would live? Is that possible? Can we see that from that initial diagnostic tool?
So I think a lot of kind of someone's initial illness is caused by inflammation. It's caused by kind of pressure in the brain. And these things resolve themselves when the hematoma resolves and gets broken down. So you see quite a rapid recovery in the patients that do survive the initial stroke at first, as the brain kind of starts to heal. What we're then left with is how much the patient has the potential to recover motor functions. And this kind of comes down to what we've been measuring in the PhD, which is white matter integrity. So if a patient has an intact white matter tract that runs from the motor cortex down to the spine and goes on to innervate the body, if this is intact, the patient has quite a good potential for motor recovery. And so if they survive the initial kind of insult on their brain, they can go on to achieve quite a good recovery. But if a patient has damaged white matter, it's quite hard to recover that motor function. Often someone might repurpose the other side of their brain to do this. So they kind of send the impulses down the opposite side of the brain, because your left side of your body is the right side of your brain is responsible for moving that. So you'll kind of potentially move the impulses important for motor control to the other side of your brain, but that's not very effective. So it's kind of measuring whether a patient is whether the recovery of a patient is going through that pathway, so kind of a more neuroplastic pathway, or they've recovered and their motor pathways are intact on the correct side. So measuring that from initial diagnostic CT gives us a really good estimation of how a patient will recover their motor function. That's what we'd be looking at from the initial CT scan to predict long term.
Huge thank you to Colony Coworking for continuing to support the Preventable podcast. Now, at the Natalie Kate Moss Trust, we have a huge ambitions to completely change the landscape of brain hemorrhages. And whilst we're a small but mighty team, we are all working remotely. And in truth, that's part of our strength. Remote working means that we can connect with incredible talent from across the UK and around the world, helping us push forward faster and smarter. But without a central office, we need flexible, inspiring spaces where we can come together to work productively, collaborate meaningfully, and work on this huge goal we have set ourselves. That's where Colony comes in. Colony is a growing network of beautifully designed co-working spaces here in Manchester, home to creatives, founders, freelancers, and teams of all sizes. They are spaces built for focus, connection, and progress. Not just a place to work, but an environment that actively supports your growth. And they've helped NKMT do just that. To find out more about how Colony could support your business, check the link in the show notes. And presumably then that could really help. I mean, this is like longer term now, I imagine, in terms of like the implementation of this. Mm-hmm. But presumably if, the NHS is a complicated beast, but that could inform, the right pathway you put a patient on in terms of their rehabilitation. Mm-hmm. Because I know that sometimes people can get a bit lost in the system, particularly after a brain hemorrhage, and they don't know where to go. They don't know the right support. There's waiting lists and this, that, and the other, and it's really challenging to, adapt to a whole new life. But presumably if you've got that data to almost kind of like show the severity of somebody's disability or rank them, I suppose, in terms of like what sort of needs that, or support that they're going to need, that could really help in terms of putting people on the right pathway to get the right rehabilitation support.
Yeah, exactly. I think the kind of physiotherapy and rehabilitation you need if you've got kind of an intact motor pathway, motor pathway versus kind of this neurocompensatory recruiting the other side of your brain. The kind of physiotherapy you need if you've had that happen is quite different. I think there's been a lot of studies showing that some kind of the more traditional physiotherapy methods aren't as effective on patients who don't have that side of their brain intact. And we have a physiotherapist involved in the project who knows quite a lot about the different kind of recovery pathways of ICH patients, which I think has been really important and has taught me a lot about,
I'm sure,
about the actual recovery side, because I think it's quite easy sometimes for me to focus on the images and the computing, but I think it's really good to have this kind of clinical kind of family around to focus me more on the clinical aspects.
Well, it's like what you were saying right at the beginning, when you were saying you were working on some things in the lab and you were looking at I can't remember that you were saying something like a particular particle or whatever, but it was like, well, what does that mean in reality? And, where does that lead? And I think what's great when you're working on a project like this, not only are you looking at it from a research perspective, but you're starting to think, okay, well, actually, if we trialed this in a clinical setting and then beyond that, working with the physios as well, it brings it to life a little bit more, because I would imagine there would be a danger of somebody working in a lab and it not really having that like real life lens on it as well. Like, how would this work, in a real sort of clinical setting? I imagine that's a challenge.
Yeah, absolutely. I think on one side, it's really important to have people in the academic sphere around you from different backgrounds. So say the ICH group at Manchester, we've got preclinical scientists, clinicians, and now some kind of physicists, computer scientists, imaging scientists. And I think it's been really important for gaining perspective. So, I go to the ICH meetings that we have and people talk about inflammatory markers and things that I did not know about or understand at the start of my kind of journey into this research area. But now, whilst I don't obviously have the kind of in-depth understanding a biologist would have, I know what to look out for. So I think having a big and kind of team with diverse interests and specialities is good. But kind of beyond just the academic sphere, I think it's really important to have perspectives of people who've gone through this, so stroke survivors. And as part of this project, we've spoken to kind of a big group of the Jeffrey Jefferson kind of patient population involved in research. This is a prognostic model, and we're kind of assessing how well people are going to do after stroke, but how well you do after stroke is kind of an individual measure, I guess. We were talking to someone who just mentioned that before the stroke, they would have said this kind of a certain level of disability. They thought, okay, well, this isn't a quality of life for me. This isn't what I want. I would not want interventions to be done to keep me alive if this is going to be what will happen to me afterwards. Whereas they were saying that kind of after recovery, after the stroke, their mindset changed and they realized that even though they did have these disabilities and their life was a lot different now, it was very much worth living. And kind of afterwards they thought, well, of course I want this. And I would want anything to be done to let me have this. So I think going more kind of beyond just binary categories of good outcome, bad outcome, there's a whole lot of nuance there, which is kind of impossible to understand as just academics in a lab.
Yeah, there's the emotional side of it and there's the lived experience side of it as well, isn't there? And I think, I think it's probably more stark, that contrast between, the research and actually the real life stories there. But we see it as well in the charity, when we're talking to people, what do they want to hear? What's important to them? We need to lean on that as well. Obviously we've got our clear mission, ultimately changing the landscape of brain hemorrhages, reducing the number of cases, improving the outcomes for people. But there are an awful lot of people out there who need additional support, who want certain answers, and that, particularly the podcast as well, episodes like this, hopefully give people that information. And I think speaking to that community is so incredibly important to inform the work in order to create real change within this landscape as well. In terms of implementation, so if all being well, this project kind of, goes according to how you, or goes in the way that you hope it would. And it's, the tool is then built up to a way that can be kind of rolled out, let's say, into NHS hospitals and, across England. How would that work? What would that look like?
Yeah, I think that's a very interesting question. And it's something that didn't really think much about in the early stages of the research. I was kind of more focused on the answers, but now trying to build this tool is something that we need to think about more and more. And I think there are a lot of regulations we have to adhere to. So there's different different categories that you need to fill, whether it's a diagnostic tool or kind of like a supportive tool. One kind of option would be we kind of create almost like a super diagnostic CT scan. So we have our suite of models which kind of run in the background, and in the foreground is a graphical user interface. So we have a CT scan that's annotated with our white matter segmentations, our hematoma. We say we can see these several signs inside the hematoma, which mean that the patient might have hematoma expansion, and the probability of this would be this, and kind of display that below. And also kind of just display the likelihood of a patient going through these kind of various different outcomes. So kind of have almost like a dashboard for a clinician to take all of this information in, and then make a informed decision with all of the information we can get. There's more of a kind of predictive modeling side, where we kind of just give a likelihood of a patient having this motor outcome after this intervention, which is quite I think a complicated statistical thing to model. It's sort of causal. So we say, if we intervened in this way, what would be the chance of the patient having a good motor outcome versus if we intervened in this way? And I think all of these things have different regulations that we need to adhere to. But I think one of the main things is validation. So once you train a model on a data set, you then need to prove that it can hack stuff outside of the data set. So if you the normal way of testing a model would be to reserve 20% of your initial data set unseen, so not used in training, and then see how well the model does on that, because you have the answers basically for that on what you used to train the model. But that's still the same data set, so you need the same kind of data set. Often the scans will be taken on the same scanners, or with the same kind of patient population. Okay. So once we've kind of developed this model, we need to make sure that it can perform well on other patient populations. And something that will be maybe a difficulty during this project is that the data sets that are available are clinical trial data sets. So they're data sets of patients who have had experimental treatments, which means they have a lot of imaging and a lot of outcomes recorded. But we need to see whether this works in the real world. So the plan is to validate this on real world data sets. So diagnostic CT scans of patients who've had ICHs as not part of a clinical trial, to make sure that the model still performs well in this population. So that's one of the main things that people look for, is a well-validated model that performs well in all of the populations that you'd be using it for, not just kind of an ideal, kind of almost perfectly well-curated data set that it was trained on. Yeah,
I feel like there's quite a lot of challenges, I suppose, like you're saying about just developing the model in the first place. But I'm sure people are listening to this and going, oh, okay, that's really great, using artificial intelligence to help with making decisions about people's health. But potentially, well, what if it goes wrong? Yeah. What if the machine, sounds quite old saying that, this machine says something and predicts something that isn't actually right, and therefore somebody gets the wrong treatment that they should have had. How does that line up? What are the potential challenges that we could see with this, and how do we kind of manage them? Yeah, so I think obviously that is the main concern about using these kind of AI prediction models, which can often be the term is a black box. So something goes in, and then a number comes out, and you have no idea what's going on in the decision-making process. So you can't really tell how much you trust it.
basically. So I think explainable AI is a big thing, which is why we're kind of maybe trying to focus on more of the annotated CT scan part of it. So using this as information, extra information for a clinician, but the clinician is the one that makes the decision. So this is kind of, it's never supposed to replace a doctor or a healthcare provider in the decision-making process. It's just to give them more information to support to support their decision. But I think there are kind of standards at which the model would have to be held to in order to be used, even as a decision support tool. So it would need to be definitely accurate enough that that there would be there would not be many cases where it would make a completely wrong decision. There's also things in the kind of explainable AI sphere that you can use to give the clinician some idea of how confident the model is in its prediction. So the model could state how that potentially it wasn't that confident in one of the predictions it made, and a clinician would take that into account when using it to inform their decision-making process.
Thank you to our sponsors, Hugh James Solicitors, for supporting this second series of the Prevent the Preventable podcast. Now, sudden brain hemorrhage can turn your world upside down, but discovering it was caused by a medical mistake makes it even more devastating. While nothing can change what's happened, Hugh James's medical negligence team is here to support those who suffered brain injury or bereavement due to medical errors. And their support doesn't end there. The Hugh James Wills and Estate team is also on hand to help you plan for the future with clarity and care, because when the worst happens, the last thing you need is added complexity. To find out more about how they can support you and your loved ones, head to the services page on our website and book a free call with them to discuss your concerns. You can find the link to all of that in our show notes. Okay, that's really interesting as well. So it almost expresses an opinion.
Yeah.
That's very interesting. I think that's the main thing. I think that's the main thing with any AI tool, whether you're using it on a day-to-day basis like ChatGPT or, whatever, but having that oversight of a human element to it. I think we're still in really early days with artificial intelligence, so to speak. And it will only evolve. But I think as it does evolve, we should always have that human element and human touch on it, particularly when we're talking about something as serious as this and actually managing people. But I do think there's a lot of opportunity within it, as obviously we've spoken a lot about today. And actually, if we can be clear in terms of having that diagnostic tool early on, given everything that you said about the fact that, treatment at the moment or the options of treatment are few and far between, actually having more information and more options presented to clinicians, to doctors at that critical point, the better, really. And actually, the more information that we have, whether it's through AI or however, the better as well. So it feels to me like this is something that, more people are going to be kind of looking into, researchers as well, and maybe not even just in this field, but in countless other fields as well. And how do we use AI to move forward? And I imagine there might be a little bit of we need to get AI being optimized as quickly as possible, but presumably there's a bit of a risk presented with that. But how do we move this forward then? What are some of the things that we need to do to kind of develop this space and kind of make this more of a reality, so that we can, as I say, improve those diagnostics and improve that prognosis for people as well?
Yeah, I guess I feel like kind of being part of the AI research sphere, I think there's a real problem with translating academia to clinical practice. I think you go to conferences on AI for medical imaging, and you see some really, really interesting and cool things. Kind of really, really cool models made by someone who's really passionate about what they do and really, really interested in the academia and the science part of it. But after that gets published, often it's kind of left, or there's kind of a competition to see who can make the best model, who can add 0.005% accuracy to their accuracy rating by changing some of the neural network kind of building blocks around, which I find quite frustrating sometimes. I think, well, okay, we can improve this. We can spend 10 years improving it little bit by little bit by little bit by using different kind of model architectures. But when is this going to be put into clinical practice? So I feel like there has to be some kind of bridging points between the pure academia side of this and clinical practice, because you go to a lot of these conferences, a lot of these meetings with kind of the medical imaging AI people, and there's just some really great ideas and some things that could have a lot of impact. But I think there maybe needs to be more research and funding and just kind of more awareness into how then we translate these into clinical practice. So potentially just having, I don't know, like clinical liaisons and giving people some training into how they need to change things and how they need to package it and validate it and go through all of the guidelines in order to put it into clinical practice.
I think that's really, really interesting, because I think, you know, from what I'm hearing is that there's a lot of really helpful information out there and a lot of great research that's already being done, a lot of great information that's coming out of it. But there is some sort of disconnect between getting that into, you know, the real life sphere of like actual hospitals and moving it forward. Is that, in your opinion, is that just mainly down to funding? Is that mainly down to systems? Or is that just kind of like we're still kind of stuck in this old way of they're the researchers, these are the clinicians, and there's not that bridge, as you kind of said?
Yeah, I think it's somewhat down to knowledge. I think for a machine learning researcher, you kind of have no idea how to implement this as an actual clinical tool. It feels very scary. It feels like something that potentially only a massive company would have the resources to do, dealing with the regulations. And I think it also comes down to sometimes incentives. I think researchers often are pushed to get paper after paper after paper out, and you don't have that many measurable pieces of impact if you spend 5 years trying to develop a model to put into clinical practice, as opposed to if you spent 5 years writing 5 papers and to get more citations, which is kind of how you advance through a lot of the academic field. So I think a lot of people struggle to find potentially the time and I guess just the kind of the people to know in order to put this into practice.
Yeah, I think what's really exciting about particularly the Jefferson Brain Research Centre that's been set up at the University of Manchester is, and it feels to me like there is a bridge there. They're very good at drawing in different people that work in different projects that can complement one another. And actually, because they're so connected with particularly like the Salford Royal Hospital and different hospitals around Manchester, some of the clinicians in those hospitals also do research works in the university, and there's not as much of a divide. And from my understanding, everyone's very collaborative as well. And I think hopefully, and from what I've seen, that does really support in, you know, getting things out of research, getting things out of the labs and into the hospitals. Not necessarily quicker, obviously, as you've already mentioned, there's a lot of hoops to jump through to get things into real life treatment and into hospitals. But actually, there is that bridge. And at least we've got that bridge to kind of move across to make certain things a reality as well.
I think so, definitely. I think it's really, it's a really great environment, kind of the Manchester research and hospitals kind of combined. I think I've just met so many people who know so much more than me in so many different ways. I think Manchester is definitely a great environment for this kind of research.
I think it's really exciting. I think we've had an episode with Professor Stuart Allen, the first episode of this series, and he talked a lot about, you know, the work going on there. We had an episode with Adrian Parry-Jones in the first series as well. And there's so much going on, and I think it's only moving forward at a great pace, but also, you know, and in a really great way. You know, there's a lot coming out of it as well. So I'm really excited to obviously be supporting you with this project, and obviously the Nathan Kate Moss Trust supporting you with this project as well. And maybe in the next series, who knows, we might have a huge updates and we can bring you back on as well. But
hopefully.
What I'd love to just finish on is, what's one message you would like to share with our listeners about the importance of this research and particularly awareness in this field, you know, of brain hemorrhages?
Yeah, okay, that's an interesting question. Just remain hopeful. I think, like you said, we have a massive problem about kind of pessimism, attitude in, I guess, patients, families, but also clinicians. Sometimes you think, okay, well, what can we do? But we're showing that you can do a lot. And there are so many emerging treatments and so many ways that we can kind of improve a patient's pathway through the system coming now. So I would just say kind of remain hopeful for people, and also for people in academia. I think I just think there's good things coming in this field of research, and recent clinical trials and recent studies are just showing that we're discovering more and more and more. So I think a message of hope, maybe.
Yeah, great. Thank you very much. We've got more information about your research project. Obviously, we've been into it in quite a lot of depth today, but we've got articles on our website about it as well. So we'll link them in the show notes too. But Olivia, thank you very much.
Yeah, it's been great to talk to you. Thank you so much.
Thanks. Thank you so much for joining us on today's episode of the Natalie Kate Moss Trust podcast, Prevent the Preventable. I know everyone has a different opinion on AI, but personally, I'm really excited about Olivia's work. This conversation opened up an exciting window into how technology might revolutionize healthcare and why this could be a game changer for brain hemorrhage survival and recovery. And what's really exciting about Olivia's work is that through our partnership with the University of Manchester, we have a clear line of sight to the research being done and therefore the results that are coming out of it. And it's very evident where our funding is going and how it's directly contributing to developing new treatments and better hospital protocols that improve outcomes for patients. Now, with all our guests in the second series of the podcast, we've recorded an exclusive question with Olivia that you won't want to miss. Today, we asked her, looking ahead, how do you see AI evolving in the next 5 to 10 years to benefit patients with brain hemorrhage? To watch her answer, just head over to our Instagram page and join our Change Collective broadcast channel, where we share extra content, exclusive updates, and ways that you can get involved in supporting brain hemorrhage research and awareness. Looking ahead to our next episode, we'll be discussing, can you fully recover from a brain hemorrhage, and what recovery and rebuilding life really looks like. And I have no doubt it will be a very honest, but hopefully a very helpful episode for many too. But until then, take care, stay safe, and thank you for being part of the Natalie Kate Moss Trust community.